A company selling widgets has found that the number of items sold, X, depends on the price P at which they're sold, according to the equation X equals 30,000 divided by the square root of 4P plus 1. Due to inflation and increasing health cost benefits, or health benefit costs, the company has been increasing the price by $5 per month. So this is a change of the price, and that's going to be dp dt. Find the rate at which revenue, key term here, we don't have revenue yet, is changing. So how revenue is changing when the company is selling the widgets for 160. So whenever P equals 160. So this gives us what we can substitute in to get an actual number answer and not some expression. So revenue is going to be the price times the number we sell. And we have a function here that can replace the X. So making revenue a function of just P equals P times 30,000 divided by the square root of 4P plus 1, or 30,000 P over 4P plus 1 to the 1/2. When I'm taking derivatives, I find it much easier to have it as an exponent instead of a radical notation, but maybe you don't feel the need for that. I do. So we're going to take the derivative with respect to t of this is talking about how it changes with respect to time, of our r of p equals derivative with respect to t of 30,000 p over 4p plus 1 to the 1/2. Now on the right side, or the left side's pretty straightforward. We're just looking at dr dt, and that's our ultimate goal right there. That's what we're after. On the right side, notice we have a fraction, and so it's going to be the quotient rule. We also have a function inside a function, so that's a chain rule. But we also have taking the derivative with respect to t, not p. So is p a function of t? Actually, it is. We know it is a function of t. So that also is going to be the chain rule. Almost like some implicit differentiation, but anyway, not quite. So let's see. We have a numerator, we have a denominator. Denominator is low, numerator is high. So it's going to be low d high. So 4p plus 1 to the 1/2, low, and then d high, derivative of the numerator, d dt of 30,000 p minus the high, which is 30,000 p, derivative with respect to t of 4p plus 1 to the 1/2, all over the square of what's below. So we have 4p plus 1 to the 1/2 squared. So that's low d high minus high d low, all over the square of what's below. Okay, I'm not trying to drag this video out. I just want to try to be clear about how we're getting what we're getting. Oh, one more thing. Times dp dt, because p is a function of t. We don't know what that function is necessarily, but we do know what this number is. So I'm going to clean it up just a little bit here. This is 4p plus 1 to the 1/2 times the derivative with respect to t of 30,000 p is just going to be 30,000 minus, then we have our 30,000 p, and this derivative is going to be 4p plus 1 to the negative 1/2, I should say. Bring that 1/2 out front, so I'll do 1/2, we'll just fit it in there, times the derivative of 4p plus 1 is just going to be 4. All over 4p plus 1. 1/2 times 2 is 1, so it's to the 1 power. And don't forget our dp dt. And if that bothers you at all that I just put it there, just remember at this step right here we took a derivative that included the p, so it'd be derivatives 1 times dp dt. And then in this step here we took a derivative that involved a p, in fact this part right here, so it was a 4p plus 1, so we got a 4 out of it. And then we have to do the derivative of dp dt, so think of it as being brought out there, it's factored out. Okay, so let's see, this is dr dt. So now it's a matter of putting in some numbers, and our p was, if you recall, p equals 160, dp dt equals 5, so it's going to be 4 times 160 plus 1 all to the 1/2 times 30,000. Hope that air conditioner's not so too loud. I'm at a conference making videos for everyone here. And I don't say that for any sympathy, just I've started tuning out this loud air conditioner. So as I speak while I write, times the 1/2 times 4 times 160 plus 1 to the 1/2 times 4 all over 4 times 160 plus 1, and I got this times 5 here because of that's our dp dt. Yeah, okay. So I'm going to plug it into my calculator here, and we'll have an answer like this. Okay, well, put it on the calculator. One key thing I caught myself there, I had added that negative there. I forgot to have it. It was there. I forgot to bring it down, so that was added on. And so what I get from this is the 2966.94. It goes 943303 as far as my calculator goes, but that aligns with what the answer is up here. So that's how you get it. It is a pretty involved problem. There's a lot of steps to that. Okay, hope that helps.